Good morning, everyone. Well, we got two people here on Zoom. How are you doing today?
Good.
You're back.
I am back.
How was the class you took?
It was amazing. Spent a whole week working on building a chair.
Were you successful?
I was. Well, kind of. It's assembled, and then it got disassembled and boxed up and shipped home, and now I have to reassemble it.
Oh my. And I guess if you could describe the chair, is it like is it woven? Is it?
It's wood. Can you see my video?
Yeah.
I don't know.
Very cool.
It's called a stick chair.
That's very cool.
Yeah, it came out great.
And was it like a kit, or did you turn all the wood yourself?
Nope. So it was all either done with machines or hand planes.
Wow. That's like one of those things I never would have thought would be like a class that you could take. I mean, like, now that you think about it, like, oh, of course, that's
Right.
something you do, but it just wouldn't like pop in your mind like, oh, I should go take a chair making class.
Now this guy teaches occasional classes. He only teaches 2 or 3 classes a year, so I was kind of lucky to get in there.
Yeah. And is it something you'd always wanted to do, or was it kind of a spur of the moment, hey, that looks cool?
I've been reading this guy's stuff for a while, and I've been an aspirational woodworker for a while. And so I thought this would be a good way to like dive into it and actually do it.
Wow. Well, were you able to kind of catch up and watch the recordings?
Yes.
Good. So we are cruising along, and we have learned about pointers, pointer arithmetic, and today we're going to dive a little bit into how do some of these built-in string functions work. And I haven't really gone over the string functions at all. So we'll write some programs that use some of the string functions, the built-in ones, and then we'll see how they actually work under the hood. And then towards the end of today, once we get through those, then we'll go over the new assignment. And I'll just give you a brief overview of the assignment, and we'll come back probably next week. And if there are some questions about how, the assignment is kind of open-ended. So if you have any questions about it, then that would be a good time to ask those then. All right. Where should we start? Okay, so let's do this. Oh, that's not supposed to be dark. Hold on. Unplug this cable, plug that back in. There we go. That's what I wanted to see. No, it went dark again. Huh. Oh, now it's back. That's how weird. Okay, so there are some built-in string functions. Oh my, the voice is not working today. So to use the string functions at the top of your program, you just do include string.h at the top. And then that gives you access to some functions like strlen for computing the length of a string. strcat, string cat. Concatenate a string onto another. strcpy, copy a string over another. Just off the top of my head, what are some of the others? We have strchr, locate a character within a string, and strstr, locate a substring within a string. And there are some others, but those are some of the main ones there. So let's write some programs that just use these functions and see how see what they do, and then we'll dig into how they work. Let's create a new file, and let's just call this stringdemo.h. Stringdemo.c, excuse me. Let's have it start out by just prompting the user to enter a string. And there's two ways to get a string. One is to use scanf with the %s placeholder, and the other is with fgetS. And there's some subtle differences between the two of them. If you remember when we talked about it last time, not last time, but last week I think. With scanf you can use %s, but it only fetches the first word. It'll stop as soon as it sees a space or the end of the line. fgetS could be used to fetch an entire line. So it's great if you have multiple words you want to input, but it does leave on to the end of the string the new line character, the character that you press when you press the enter key. That goes into the string as well. Since I do want to do some computations possibly involving multiple words, let's go ahead and use fgetS for this. Just keep in mind that there is going to be that new line character at the end of the string. So with fgetS, there are three parameters. The first parameter is the string or the character array we want to put the string into. The second one is the maximum length of the string, in other words, the length of the array. And the third one is where we're getting the input from. Let's put in 100 as a maximum length, and we're getting it from standard input. And I can see right now that I'm missing a declaration for this string, so let's go ahead and do that. Character str, and let's give it a maximum of 100 characters. It's as easy as that to declare a string. Just make a character array, and then pick a maximum length that you want for it. And then let's go ahead and just print it out. So if we enter a string, like my name, it comes back and it displays the string to us, but there's this extra line below, and that's caused by that new line character that's on the end of the string. So the string itself contains my first name and my last name, and then a new line character at the end, and that new line character gets displayed on the screen, and then another new line character gets displayed as well, the one that I put here in the printf. So we end up with two of them back to back, and that causes this empty line that we see there. So just keep in mind that that is going to be there. Eventually, towards the end of this session, we'll figure out how to get rid of that. But right now, it's going to be there. Okay, so the first function that I wanted to show was string length. This one right here tells you how long a string is. And it's basically just going to count the characters in a string. So you just call strlen, and pass in the string that you want to compute the length of, and it returns to you the number of characters in that string. So when it computes this, it is going to, oh, what did it say here? Oh, we need to use LU instead of D, and the reason for that is that string length could return a number that is too big to fit inside of an integer. It could be, you know, a 64-bit quantity, and it's definitely going to be unsigned. String length will never be negative. So it is telling us that we need to use LU here, long unsigned integer, for our output. So it comes back and it says the length is 12. And let's see where we can come up with that. Where does that 12 come from? So we got 5 here. We got 5 here. It's a total of 10. There's a space in the middle. It counts that as well. So that would be 11. And then the 12th character would be that new line character that's sitting on the end. So when you use string length, it returns the number of characters in the string. It does not count the null character. All these string length functions never include the null character as part of their computations. So remember that that null character is just there internally to mark the end of the string, but you, the user, someone who is interacting with strings, not the programmer, but the user who's interacting with strings, doesn't know that that null character is there, and so the string functions don't actually include that when they're displaying things like the length. Okay, so let's do a couple more things. Let's have it, let's see, what could we do? Oh, I can do something like, I could say string cat. And the way this function works is it takes the second string that you pass in and attaches it onto the end of the first string. So concatenation means to stick things together. And then let's go ahead and print that out again. So we get here Barry, and then Brown, and then the new line character, and then the 3 exclamation marks. It doesn't quite look like the way that you know, I'd like it to look, but that's what we got for now. Maybe a better way to use string cat is not to start with some user input and then add characters onto it, but let's start with a string that has a known value and then add something onto that. So let's start with like character string 2, and we'll make it 100 characters, and we'll start it out with something in it. Let's put good morning into there, and then we'll attach the 3 exclamation marks onto the end of string 2, and then we'll print out string 2. We're looking at this last line down here. So we started with good morning, and then we attached 3 exclamation marks onto the end of it. So we started with good morning, and then we attached 3 exclamation marks on the end of it. By the way, if you assign a string on the same line that you are declaring it, what the compiler will do behind the scenes is after it allocates space for string number 2, it will then copy the characters from the string on the right into the string on the left. Essentially, it'll do a string copy for you. This only works if you are assigning to the string on the same line that you are declaring it. If you do that on 2 separate lines, it will not work. So yeah, so you get an error here. So if you split that up into 2 lines, you'll get an error when you try to compile it. So you must do the string initialization and the declaration on the same line if you want the string to contain, if you want the character array to contain some characters right off the bat. If you want to initialize a string so that it is empty to begin with, it is not sufficient to simply just declare the array and then stop there, because now the array is going to contain junky values. You can see right here that the string contained an @ sign for whatever reason, and then we appended our 3 exclamation marks onto the end of that, and we got this string. So be sure when you declare a string, if you are going to be working with that string without assigning to it, like with a scanf or an fgetS, that you need to initialize it to like an empty string. And the way you do that is just 2 double quotes next to each other. By the way, if you used double quotes here, that is the way that C represents a string literal, a string that is like in your program, and implicitly it's going to put that null character at the end. So the double quotes always puts the null character at the end for you. So even though it appears like there's nothing in between these 2 quotes, there's actually going to be a null character stored in the array itself. You don't see it, but it's there. Same thing here with these 3 exclamation marks. This string literal does contain the null character, and then when it concatenates it onto string 2, that null character gets copied across, so that the null character is now at the end of the new string. Okay, so that's string cat, which is used to join 2 strings together. When you're using string cat, you need to make sure that the string you are appending to will be big enough to hold the sum of the original string plus the new string. So if string 2 here was, let's say, only 10 characters long, and I try to put these 3 exclamations on the end, I need to make sure that string 2 is actually big enough to hold it. String cat will not, as with every other array function pretty much, will not check to make sure that the string is big enough. If you try to append a string onto another string and the first string isn't big enough, it will just simply overwrite the array and keep going. See, there's a question. Why didn't we get the exclamation mark at the new line with string 2? Oh, so maybe I'll make a picture here. So here was string 2. Which contained good morning, and then a null character. And actually, it's not even this short. Remember, I allocated 100 characters for this string, so it's much longer. But the null character sitting right here effectively marks the end of the string. So there's about, 10 characters here, plus the null character, and that means there's about 90 characters of just garbage sitting behind the string itself. So the character array has 100 characters in it, but only this much of it is actually valid data. Then I did this, string cat, string 2, and then 3 exclamation marks. So this string right here, the 3 exclamation marks, internally is 3 exclamation marks and then a null character. When string cat goes to work, it's going to take each of the characters out of the second string and put them onto the end of the first string. So it's going to essentially, it's going to scan forward, look for this null character, and then the first character out of the second string overwrites that one. So we're going to come through here, we're going to obliterate this and replace it with the exclamation mark. And then the second character goes here. Then the third character goes right behind that second one, and then this null character is copied over and placed on the end of that string. So Notice that the null character that was here is no longer there. It has now effectively been moved over to the end of the new string. So the new string is now 3 characters longer than it was before. So maybe the question was, why didn't we get a new line character before the exclamation marks? And that was because our string 2 here doesn't contain a new line character. Our string literal doesn't have a new line character in it. If we wanted to put a new line character in it, we would actually explicitly put one in with a \n. But we didn't put one in. So there was no new line character at all. The only new line character that appears on the output is the one that I'm printing out using my printf statement here. That's string cat. String cat takes a second string and attaches it onto the end of a first string. A moment ago, I said if you want to assign to a string, you have to do it in one line. If you break it up into 2 lines, it's not going to work. And we saw that there was, in fact, an error generated by the compiler. So the way to assign to a string after you have declared the array is to use the string copy command. The string copy function takes the second string and overwrites the first string that I passed in with the contents of the second string. So whatever was in string 2 before will get erased, and the contents of the second string that gets passed in goes over the first one.
Does this mean if you add a string that's shorter than the original one, it will just copy over the first part and then leave the second half?
Yes, but
Okay.
there will be a null character sitting there marking the end.
Oh, I see.
So I guess what you're asking here is, let's say we assign this to be my whole name right here, and then we do a string copy of something shorter. And let's do, I don't know, let's do,
Yeah, that would work.
yeah, I know, but the problem is that it's not going to be obvious, right? Because it's just the first part of my name. Gosh, now I hate this creative part. It's like I need to come up with something. So usually I just look around my desk and then I pick something that I see sitting on my desk.
Pen.
Pen. All right. And let's take out the string cat for now. And I'm actually gonna comment out all this stuff up here because I'm getting tired of entering fake strings over and over again. Okay, so your string is pen. All right, so what happened there? So we started out with a long string. Its contents is my name. And there's a null character sitting at the end to mark the end of the string. And all this stuff behind that null character is just junk. And then we wrote string copy str2 and pen. And this string right here, this string literal, is pen and a null character. What happens when we do the string copy? So it starts at the beginning of string 2, and it starts at the beginning of the string literal here, and it takes the first character and it puts it there. So a P goes right there. And then it takes the next character and it just puts it right there. So we get an E, and then we get an N, And then finally this null character is stuck on the end of that. And we get a null character there. So the last half of the string is still there. It's now just considered junk values because the end of the string has been marked by this null character. There's now 2 null characters in the string, but only the first one counts. See, all the string functions are actually really mindlessly stupid. All they do is they start at the beginning of the array and they march their way towards the end of the array. And when they hit that first null character, they're just going to stop. They're not going to look beyond that first null character to see if there's anything else there. As soon as they see a null character, they stop. And one implication of that is that if there's no null character, they just keep going. Right? So if you have a string that has no null character, it'll just keep marching forward until it finally finds one or until the program crashes. I just turned down my microphone because I saw that I was overloading the amplifier. So hopefully it's not so distorted, but you might have to turn up the volume a little bit. Now, when you're using something like string copy, you don't have to put a string literal here. You could put, another variable that represents a string. Like we can do a character string 3. Let's say we put Barry into that one, and we put Brown into that one, and then we say string copy.
Are we supposed to be seeing your code screen?
Yes, of course you are.
Okay.
All right, so I shortened string 2 to just be my first name, and I have string 3 here, which is my last name, and then I'm going to copy string 3 onto string 2, and we should see, or actually before I compile and run it, what do you think we're going to see?
Brown.
Yeah, we're just going to see Brown. Okay. What if I change this to string cat?
Then we'll see Barry Brown with no space in between.
Right. So how do we get that space in there?
Put a space in there.
How do we do that?
You can put it into either of those string literals.
Well, let's do it without that. So let's say we prompted the user to type in their first name and last name separately, and now we want to stick it together.
Then you could use string cat to add a space before, before the one you've got.
You just have to call string cat and string copy a couple of times to get this done. In Java, all you have to do is say something like string 3 equals string 2 plus, and then a space, and then plus string 2, or something like that, right? You just join things together with the plus. So Java makes it nice and convenient. You can just use plus to join strings together. But behind the scenes, Java is just calling an append function. So when you use plus, it just turns that into a method call. And joining strings together like this involves 2 method calls, one here and one here. So in C, you just have to do it kind of by hand and one little piece of the string at a time, but you'll accomplish the same thing. All right, so we've talked about string length, string cat, string copy. Maybe it's time to start looking at how these functions actually work. Let's start with string length. That's kind of the easiest one. So let's say we've got a string here. And that string contains hello. and a null character. To figure out how long this string is, all you have to do is count how many characters you see. And when you get to that null character, you just stop. So you start at the beginning of the array, and you march your way towards the end of the array, or march your way towards the null character, and just keep a count as you go. As soon as you hit that null character, you can stop and return whatever that count is. So the function that we're going to write that does exactly that is pretty much identical to the one that's built in. It's not like we're doing one that is simpler or doesn't have as many features as the one that's built in. The one that's built in is really no more or less smart or stupid as the one that we're going to write. So let's call this function, I don't want to call it strlen because that would take the place of the one that built in. Let's call it something else. So let's call this string length, right? It's going to return an integer, but to be passed in, it's going to be passed in a string. And we've seen now there's two ways that we could write this. We could do it as character array, and let's call it str, or actually let's just call it s. But there was another way that we could write that. Do you remember what that was?
Wasn't that using the pointer?
Yeah. You'd say character star s. And what that means is this function is going to be passed in the address of a character. And that's essentially what a string is. A string is just an array of characters, and that array is just the address of the first character in the string. So whether you pass in a character pointer or a character array, it makes no difference at all to the compiler. Both of them are the same thing. You're being passed in the address of a character. It just so happens it's the first character of the string. You do not need to pass in the length of the string. Strings are different than character arrays in that strings always have that null character at the end. So we don't have to pass in the length of the array or the length of the string because our function will take care of that by stopping when it hits that null character. So to implement this function, all we need to do is have a counter. We'll initialize that to be 0. And then just a little loop here that says while the, actually let's not call it, let's call it I. It's just our usual generic variable. So while the ith character of the string is not the null character, increment I. Okay, so we're going to look at the ith character of the string, and we're going to start that at 0. And as long as that is not the null character, increment I, so go to the next character in the string. And then when it is equal to the null character, this is going to be false, so it will jump out of the loop, and then we can just return the value of I, whatever that happens to be. That's it. That's how string length works. Okay, let's come down here and let's put back these lines of code and let's replace this with our string length function. And now because our string length returns just an integer, we have to change this back to a D. All right, it says the length is 12. That's exactly what the original string length function returned. So that means our function is performing this calculation the same way as the built-in one. So let's look at it again. Initialize I to be 0 as long as I is not equal to the null character, increment I, and then when it is equal to the null character, break out of the loop and just return the value of I. So it will march forward through the array and stop when it hits that null character. Now, somebody asked, can we do this with a for loop? Sure. The for loop is just a condensed version of the while loop. The initialization, the condition, and the increment could all be put inside of that first line of the for loop. Let's see what that would look like. So I'm just going to put for in front of this, and then I'm going to say integer I equals 0, semicolon. I'm going to take the condition and put it right here. And then I'm going to take the increment and put it right there. So what does that leave for the body?
Nothing.
Nothing. So semicolon, no body. If you really want it to be like clear that there's no body, you could actually put a set of braces in, and you have the same thing. All right, we got an error.
Oh,
Here on line 12. What's going on?
well, the I is out of scope.
Right, so the I was declared within the loop. And once we jump out of the loop, I doesn't exist anymore. So we're going to have to like put the variable I up above and then take away the declaration inside of the for header. There we go.
So if you had forgotten to take away the declaration in the for loop and it still said for int I, would that then return garbage?
Yep.
Yep.
Because now we've got two I variables. We've got one that exists in the function, and we have another one that exists only within the loop. So the inner one here is the one that's getting incremented. When we come back to that return I down here, then it's returning the value of this I on line 6, which we did not initialize to anything. And we get a junky value. I'm wondering if running it again gives us a different value, and it does. So it is just garbage. Somebody asked on one of the discussions, like, well, I don't know if they asked, but they said one of the reasons they preferred, or they pointed out that in C#, you get an error when you try to do this, or at least a warning, when you try to declare a variable in an inner scope that would essentially overwrite the variable in an outer scope. And notice that when we did this in C, there was no complaint at all. It just did it. Whereas in C#, it would actually issue you a warning. And that is not a feature of the language itself. That's just a feature of the compiler. The C compiler, by default, does not flag instances where you are, this is called shadowing, when you are shadowing one variable with another. The C# compiler does flag that by default. But you can turn on that behavior with our C compiler just by telling it to. Can pass in this -w shadow, and that tells it to issue you a warning if you're trying to shadow a variable, if you're trying to declare a variable in an inner scope that would overwrite or overlay a variable in an outer scope. So it just issues a warning now. But that, like I said, is not a feature of the language. It's a feature of the compiler. And it might be possible with the C# compiler to turn off that behavior so it doesn't give you a warning.
Yeah, that was me. And so I hadn't made the distinction between language and compiler. So that was interesting.
Good. Now, I suppose it is possible, though unlikely, that the language specification for C# says that compilers must flag shadow instances, but I don't believe that is specified for C, that compilers must not flag shadows. They just don't by default. Okay, so that's string length. And I guess the last thing to show you is, since we have an empty body here, we could actually take out the braces and just stick a semicolon on the end. It'll work the same.
You want to get rid of that declaration in the for.
Oh, yes. Thanks. All right, let's go on and do, let's do, I have a list of ones that I definitely want to do. Let's do something like, let's make a totally different one. Let's make this one called count uppers. And its job will be to go through the string and count all the uppercase letters and return the number of them to you. So I want to be able to just call count uppers, pass in a string, and it tells me how many there are. How would we go about doing this? So it's kind of similar to string length, but we're not counting all the characters. We're only counting the uppercase letters. We'll do the same kind of loop we had before. You start with I starting at 0, and then you're going to march your way towards that null character. So all your string functions are pretty much going to have this template for a loop in it. You initialize I to be 0, and then while the ith character of the string is not the null character, you're going to be doing something inside that loop. So in this case, we're going to need two variables. We're going to need one that counts the ith characters, marches our way through the string, and we're going to need a second one to keep track of how many uppercase letters we saw. How will we be able to find out whether the ith character of a string is an uppercase letter?
You test it for the range from capital A to capital Z.
Mm-hmm. So you can say if the ith character of S is greater than or equal to a capital A, and the ith character of S is less than or equal to a capital Z, then it must be in the range of capital letters, uppercase letters. So if that is true, we'll increment uppers. And also, don't forget to increment I, or your loop will run forever. So regardless of whether we found an uppercase letter or not, we're going to increment I. Oh, and then finally, when we're all done with the loop, return uppers. So this comes back and says there are two uppercase letters. There are some comments about possibly shortening the loops a little bit. And you're right, there are ways to shorten the loops. We will get to that in a few minutes. But I want to write these functions first. Okay, so that's count uppers. We need two variables, one to keep track of our character as we're counting through the loop, and another one to keep track of how many uppercase letters we saw. Okay, so another one. Let's call this find or. And what it does is it finds the two character sequence OR. And it doesn't have to be capitalized. Let's just make them all lowercase for simplicity's sake. So find the two character sequence OR within the string and tell me where they are. In other words, give me the index of where it is. So if OR appears as the first character of the string, it'll return 0. If it occurs, a little further down the string, it might return like 5 or 10. Basically, it gives you the character index of where that two-letter sequence starts. So we're going to have the same kind of loop we had before. Start at the beginning, go all the way to the end. And then I'm going to remember to put the I++ in there. I always seem to forget that. And then my program runs forever. But what do we do in here? How do we determine if the characters we're looking at are OR? So here's what we can't do. Okay, we can't do this like string comparison like this. Right, this is a single character and this is a string. So these two will never be equal to each other. We'll probably get a warning or an error from the compiler saying you can't do this. You can't compare a string to a character. So we're going to have to do this a character at a time. We're going to have to look at the ith character of the string and the next one. We're going to check to see if the one we're looking at, the ith character, is an O, and also the very next one is an R. So if this one is an O and the next one is an R, then we've found it. So if the ith character is equal to the single character O and the I+1 character is equal to an R, then we found it. So as soon as we find it, we could then just return the value of I. We don't have to go any further. But we need to handle one more case. What if we scan all the way through the string and we never find it? What if our string doesn't contain those two characters anywhere in it consecutively? What should we return in that case?
A negative number.
So we can't return a positive number. And the reason for that is our find or function returns positive numbers if the string was found within the larger string. So we're going to have to return something that isn't one of the valid values. And a common thing to do is return a negative number, usually -1. Because if we found it, well, we're going to return a positive number. So a negative number would never occur naturally. We'll use that for our errors. So if we get all the way through this loop and we never break out of it, we never return I, then we'll just return -1 to indicate that we didn't find it. We shouldn't return 0 because 0 is also a valid value. If the OR was found at the very beginning of the string, then 0 would be what we should return. So we shouldn't return 0. A negative number works well. let's put in a string. Let's put in something like good morning. And here it says it found it at 6. 0, 1, 2, 3, 4, 5, 6. And if we type in a string that does not contain or, like good evening, then it says it found it at -1, which is its way of saying that it didn't find it. And we should try a few other things. Like let's put or at the beginning of the string. I typed in orange, and it came up with 0. That's good. And now let's try putting or at the end of the string. Here it says it found it at 3, which is good. 0, 1, 2, 3. And there's actually another case we need to try. So we've got or in the middle, we've got or at the beginning, or at the end, and we've got no or at all. So that's, what was that, 4 cases. There's actually a 5th case that we should consider.
That be the letter, just the letter O at the end?
Yeah, what happens if it's just the letter O at the end? Remember, the way we implemented this, it's also going to check the next character. If it sees the O, it then checks the next character. Trying to think of something that ends with O. Doesn't matter.
Hello.
Oh, yeah, there we go. Hello. Right? Right. Still says -1, so we didn't get a crash. And I suppose that's okay. I mean, I would still be a little nervous about this. We're going to use the same string we did before. It just happens to have hello in it. I'm just going to make a copy of that. Okay, so we're marching our way through this string. This is not an O. This is not an O. This is not an O. Oh, by the way, let's look at the code itself. It says if the ith character is equal to an O and the I plus 1th character is equal to an R. So it's going to look at this character and see if they're an O and an R. If they're not, it'll then march forward to the next one and see if this character and this character are an O and an R. And they're not, so it marches to the next one. OR, it's not. OR. And then what happens here? So it's going to look to see if this character is an O and this character is an R. So it's going to look at this character and goes, oh, that's an O. But it looks at this one here and it goes, ah, it's not an R. And so it just marches to the next character, which is the null character, and then it stops. So this is okay. It didn't go off the end of the string. What it did was it looked at the very last null character and saw if that was an R. So that's still part of the string itself. So it didn't go beyond the end of the string, but it still makes me a little nervous that this is not probably a good, like, general purpose way to do this kind of function to search through an array to look for a subsequence of numbers. Because if we were doing this with, let's say, an array of integers that doesn't have that null character marking the end, then we would risk falling off the end of the array. Like if we were looking for the sequence 1, 2, 3 in our array, and we saw, and the last number in the array was the number 1, then we would look at that number 1, and then we would also look at the next one for the 2, and the one beyond that for the 3, and that would be off the end of the array. So how can we restructure this loop so that that doesn't happen? What we really need to do is make sure that the array essentially, well, You know, now that I think about it, this is probably okay because we're looking at that null character. I was saying what we have to do is we have to make sure the loop stops at 1 before the null character, not that it stops at the null character. So we could do something like I plus 1 and look at the next character and see if it's a null character. But this raises another problem of what if the string is only the null character? What if it's an empty string? Then it will never see that null character. It's always looking 1 past it. So I don't know if this is a huge problem here. What it might be more of a problem is if we were looking for a longer sequence. If we were looking for, let's say, like ORX, right? Then we would have a problem of looking 2 characters beyond the end of the string. So I don't know. I don't know if that is going to be. I think it might end up just sort of clouding the intent here. But the other thing I wanted to bring up was in this picture I drew over here. I said it was looking at this first character, let's say, and then it looks to see if this one's an R, if it looks to see if this one's an O and this one's an R. But it doesn't actually do that. It looks to see if the first character is an O, but if it's not an O, it will actually skip looking for the R. See, look at the code here. It checks to see if the ith character is an O and the I plus 1th character is an R. But if this was false, if the ith character was not an O, then the computer knows that it doesn't matter whether the next character is an R or not. The whole condition is going to be false. Because both of them have to be true in order for the whole condition to be true. If any one of them is false, then the whole condition is false. So this is called short circuit evaluation. If the first condition is false, it won't even look at the second condition. It'll just skip it entirely. So as it's marching through this string, it's only looking at the first character. If it's not an O, it moves right to the next character and doesn't even check to see if the next one's an R. So this actually speeds up the algorithm a little bit because it only looks at one character unless it runs across an O. Then it looks at the next character. So here it encounters the O, and then it looks at the next character and then checks to see if that one's an R. So that's kind of nice. You can structure your conditions here so the most common one goes up at the front and the least common ones go at the end. And that way it'll do the short circuit evaluation and potentially speed up your code a little bit. Someone said another way we could write this is instead of looking for the null character, we could use our string length function. And we could say while I is less than the string length of S minus 1. And that'll ensure that we never go to all the way up to the null character. We're always going to stop one before the last one. I think that's actually pretty good. It's a pretty good suggestion. Why is this not working?
It should be string length, not str.
Thank you. Okay, that works fine. Now there's a couple of things to be aware of when you do this. The first one is it now needs to call string length, which itself contains a loop to go through and find where the end of that null character is. So essentially we're kind of almost duplicating the behavior here. String length itself has its own little loop that's going to go from the beginning of the string to the end of the string and then stop when it hits a null character. And now we're telling it to do another little loop to go from the beginning of the string to the end of the string, but just stop one before you hit the null character. So now we have two loops that are running. And the other minor problem with this is we're calling string length inside of the condition. So if the string is, essentially for every character in the string, we're calling string length. So string length potentially is being called many times here. So if you're going to do that, a good practice is to move this string length. Since the length of the string is not going to change, move this string length outside of the loop, so it only gets called once. Now I want to put a little caveat on that. If you turn on optimization, it's quite possible the compiler will see that the length of the string is not changing, and so it'll only call it once for you. So it might be okay to put the string length function inside of the condition and then turn on the optimizer, and perhaps it will see that it's only being called, it will only call it once for you. It sees that the value is not changing. But that might only occur if you're using the built-in string length function. There might be a pattern to look explicitly for that. If you call it anything else, like string length, it might not recognize that pattern. I'm not sure. The only really way to find out is to try it, see what happens. Nevertheless, that's a good strategy to use, is if you are putting a function call within the condition of a loop, and you know that that function call is always going to return the same value, then it might be a good idea to move it outside the loop. Okay, let's do another function. And I want to call this first word. And what this function is going to do is isolate just this first word. Essentially, it's going to shorten the string so that it's only the first word. It's going to find the first space in there and chop the string at that point. Just remove the rest of it. So the way you do that with a string is not to remove the other characters. And I guess it's a bit of a misnomer to say remove something, because in computer programming, you never remove something. You only overwrite it with something else. So we're not actually going to physically get rid of these other characters. What we're going to do instead is just put a null character where that space was. We'll leave the other characters there. They just become junk at this point. By putting in the null character where that space was, we effectively truncate the string at that point. Remember, all the string functions just go until they hit the first null character. So if we then ask it what the length of the string is, it's just going to go to the first null character and stop. Now this function is going to be void because it's going to modify the string rather than compute some value. So we'll do the same loop we had before. We'll start at 0, and we'll say, while the ith character of the string is not the null character. And the reason why we're doing that is because it's possible that the string we're looking through doesn't have a space at all. So we'll want it to stop when it hits the first null character. But if we encounter a space before then we'll just stop at that point. So if the ith character of the string is equal to a space, then we'll replace it with a null character. And at that point, we're done. So we can just return. Okay, so we start I at 0, and while the ith character is not the null character, if it is a space, replace it with a null character, and then return. And if we get all the way through the loop without replacing anything, that's fine. There's nothing to return from this function. We're not going to put a return down here at the bottom because since this is a void function, we're going to return anyway, but there's no value to return, so we don't need to put in a return followed by a value. And then don't forget to increment I. So let's call first word on our string, and then we'll print it out. Okay, we got a warning. It says I'm trying to do an assignment inside of a condition. The reason why this is a warning is because that's actually allowed. It just looks weird. Oh, didn't work. That's odd. I'm looking at this going, didn't work. I didn't expect that. Let's take a look at our code here. First of all, am I calling first word? I am. And I'm passing in the string, and it should isolate just the first word. So we're going to start I at 0. While the ith character is not the null character, if it is a space, then replace it with a null character and then return. If it's not a space, increment I, go to the next character. So I guess that means it's never finding that space, which I did put in there. It's right there. I see. The comment here is I used equals instead of not equal, like all my other loops here. But all of my other loops used not equal. Good catch. Because I was going to stare at this for a long time and not get that. So what happened by putting equals there is the loop was false right off the bat, and nothing happened at all because the first character was not a null character. Oh, that's better. So we've isolated that. So that's how you truncate a string. That's how you shorten a string, is find the place where you want to mark, where you want the string to end, and then just put a null character there. That's all you have to do. All the string functions will just stop when they hit the first null character. Doesn't matter what comes afterwards. So remember that technique. It's going to come up later in the semester. If you want to shorten a string, find the place where you want the string to end, and then just put a null character there. And that will effectively shorten the string. It doesn't shorten the array. The array still holds, in this case, 100 characters. But we've just marked the end of the string with a new null character that came before where the old one was. Okay, one more function. And then we'll be done with these. And that is, remember earlier I said when you use fgetS, it puts a null character at the end because that's what the user typed. They typed the return or the enter key, and that went into the string. When we print the string out, that null character appears. And usually we don't want that there. What we'd like to do is get input from the user using fgetS so they can allow multiple words, but we want to get rid of that new line character so that it's not there. Most of the time we don't want it. Some programming languages, like Python and Java, come with a method or a function called trim. You pass in a string that you want to trim, and it goes and it finds those trailing spaces, and it gets rid of them by effectively shortening the string. We're going to do the same thing. We're going to write a function called trim, and its job is to get rid of that new line character on the end. So how do we do this? So there's a couple of conditions we have to take into account. One is the new line character might or might not be there. So if we pass it a string that doesn't contain that new line character, we shouldn't alter it. And if the string does contain the new line character, we should get rid of it. Here's what the user input might look like. Hello, followed by a new line character, followed by the null character. We want to get rid of this new line character right here. Any ideas?
It's kind of like first word, except instead of looking for a space, you look for a new line.
Okay, so
right?
that would find a new line character and then get rid of it, right?
Yeah.
But we don't, here's one of the things to think about. We don't want the first new line character, we want the last one.
Oh.
Like what if the string contains a new line character? We probably want to leave that there. We just want to get rid of the one on the end.
So you have to find the length, start at the end, and move forward. And look for the last new line.
Well, so we could find the length, right? And then that'll tell us how many characters are in it. So in this case, it'll return 6. The 5 letters for HELLO plus the new line character returns 6. So we could maybe like go to the end of the string and then look at the one right previous to that and see if that's the null character.
Right. And then just keep decrementing I until you either find a new line or get to 0 or -1.
So we could essentially work our way backwards, right? Well, I guess let me backtrack a little bit here. So the trim function in other languages don't just remove that trailing new line. They also remove any other spaces that are back there. Like if I type in hello and then space, 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 and then press enter, they get rid of all of those, leaving just like, the idea is, have you ever, this irks me to no end. Like you go to a website and it says enter your credit card number, right? And so you enter your credit card number and then like you accidentally press a space after that last character and you press enter and it goes, that's not a valid credit card number. And you're like, what's wrong? I don't see anything, missing there. And it turns out there's a space at the end. And I'm thinking, how hard would it have been for the programmer to just call trim after getting input from the user and just get rid of that space instead of like barking at the user because they typed a character that they literally can't see on the screen. Have you ever done that? Like you like click on to the right of your input and see if the cursor's not like right next to the characters you type in, and then you delete any characters that were there, and then sometimes you do the same thing on the left-hand side, right? Just make sure there's no spaces in front. It's like, couldn't the programmer have spent 10 more seconds to just solve that problem and just got rid of those spaces?
I've had that occur for Canvas quizzes.
Oh, and it marks it wrong, right?
Yeah.
I was like,
I mean, you can all usually just talk to the teacher and they're like, yeah, whatever. But,
yeah, also the teacher like looks at it and goes like, it looks like your input is right.
Exactly.
Right? Because they can't see the space. But it's there. So we'll do that. We'll go to the end of the string and then we'll march our way towards the beginning. And then what we could do is, there's a couple of ways to approach this. One is we could march our way towards the beginning, and then as soon as we hit a character that's not a white space character, like not a space or a tab or a new line, we'll keep going, and then I lost my train of thought there. We'll go backwards, and when we finally encounter a character that's not a white space character, then the very next one we'll replace with a null. And that'll effectively truncate the string at that point. And the other way to do it is march our way backwards again, and every time we find a white space character, just stick a null there. So we might end up putting several in, but that's okay, because it's only the first one that counts. So let's try that out. So we need to go to the end of the string. Now, we actually have a function that'll tell us how many characters are in a string, and that essentially will jump I forward to where the end is. So we'll go like int I equals string length of s. So if we pass in a string like hello, and then a new line character and a null, now the value of I will be 6. 0, 1, 2, 3, 4, 5, 6.
Shouldn't that be not starting at 0? Shouldn't it? Well, I mean, it's the same.
Well, I was thinking, though, we might want to decrement 1 from this, because otherwise we'll end up looking at the null character first. So we can say while the ith character of the string is equal to a space, or the ith character of a string is equal to the new line, or the ith character is equal to a tab. Those are the white space characters. Then replace it with a null. And decrement I so that it goes backwards. Okay, so as long as the ith character is a space or a new line or a tab, replace it with a null and then decrement it. And then if it encounters another space, new line, or tab, it'll replace it with a null and then decrement it. So we're going to put nulls in as we're walking our way backwards. And as soon as this loop doesn't encounter a white space character, it'll jump out. And that should be it.
There's no, what if I gets to be less than 0?
Ah, that's a good point. Like, what if the string is entirely white space characters? Then it will just keep marching its way backwards. So we should put in a condition somewhere in here to make sure that I stays positive.
You could.
So where would be a good place to put it? Like at the end?
Put it after
in the middle, or in the beginning?
I think at the beginning, because then you could take advantage of short circuiting.
I like that. So put it at the beginning, because if I ever goes negative, we do not want to be looking in the array. So if we put that at the beginning, then if I ever goes negative, it will not do this other portion of the condition, and we will not end up looking inside the array. If we put it at the end, then it will end up looking inside the array, possibly at a negative index, and then it will discover that it's negative, and that could create a problem. So let's put it up front. Now, order of operations are actually going to make this a little problematic, because OR is kind of like plus, and is kind of like multiply as far as order of operations go. So it's going to say, while I is greater than 0, and this is not a space, or these other things.
Oh.
So when you're mixing ands and ors, it might be a good idea to put parentheses in there, just to reinforce that it's this condition and all these others. All right, let's put in, let's take out this first word and let's put in trim. Oh, and then let's change the text that gets displayed. Okay, I'm going to put in hello and then enter. And after the trim, notice there's no blank line. If I take away the trim, we get a blank line, so it didn't trim it. So let's put the trim back, recompile. And now I'm going to put like some extra spaces there. Now, how do I know it actually got trimmed? I don't see the spaces.
You need to put something else in the, like put a period after the %s.
Just to make sure it's there.
Or something.
Yeah.
Yeah.
So what I usually like to do is like, not only something after, but maybe something before.
But
like,
sure.
like just to like mark, here's the beginning and ends of the string. That looks good. And then as a last test, let's put some spaces inside the string and make sure those don't get touched. And that's good too. So it trimmed off the spaces at the end, but it left the ones in the middle alone. And the final...
The empty string. Oh, is that what you're going to do? Sorry.
Yeah. Let's try an empty string. Okay, that looks good. And then finally, let's do a string that contains just spaces. That looks good too. Oh, I guess one more test. What's going to happen here? I got spaces in front and spaces behind.
The spaces in front will stay.
Yeah. And that's what we want. We want to trim off the stuff on the end. In order to trim the stuff off the beginning as well, that's a little trickier to do because we just can't change where a string starts. What we would have to do is actually copy the string down towards the beginning of the string in order to remove those spaces. So trimming at the beginning is a little trickier to do than trimming at the end. Trimming at the end is easy. You just mark the new end of the string. Trimming at the beginning, a little bit harder to do. Okay, so let's do a little recap of what we did here. We wrote a function called string length that computes the end of the string just by looking for that null character and keeping count of the characters as it goes through the string. We have count uppers that works a lot like string length, except that it also keeps track of how many uppercase letters it found. And we have find or that looks for the letters OR within the string by looking at successive letters or consecutive letters within the string. And we want to make sure it doesn't go off the end of the string by ensuring that the length or the I never gets to bigger than the length minus 1. Now if we were looking for a 3-character sequence, we would change this to length minus 2. If we were looking for a 4-character sequence, it changes to length minus 3. And this will ensure that as we're looking at the consecutive letters of the string, we never go off the end of the string. We have a function called firstWord that finds the first space within the string and that sticks a null character there, effectively shortening the string. And then finally a function called trim. Goes to the end of the string and then marches its way forward towards the beginning, replacing white space characters with nulls as it goes. Also a check to make sure we don't go off the beginning of the string. And I said earlier that the built-in string functions aren't really any more complicated than this. Now, there is no trim function or first word function in the built-in string ones, but there is like string for locating a substring within a larger string. And there is string length, and there's string copy and string cat, which we didn't write today. We didn't write those last two, but they're in there. But they all pretty much look just like the ones that we wrote. There's no check in any of these functions to see whether you walk off the end of the array. It just will walk off the end if that's what you tell it to do. So if you pass in, let's say to string cat, two strings, and the first string isn't big enough to hold the first one and the second one together, it'll just go off the end and overwrite whatever memory is there. Some people are pointing out here that some programming languages have a left trim and a right trim function separately. And then you can put the two together to make a whole trim. So it can trim off the left side, trim off the right side. And they're different, right? The right trim is a lot simpler than the left trim. So at this point, we're going to take a little break. And when we come back, we'll talk about the CSI assignment for this week. And I'm going to hold off for now talking about how to shorten these functions a little bit. The template I gave you here will work just fine. It's really, I think, self-explanatory what's going on, as long as you understand how strings work. But we'll see next time, how can we fancy these up a little bit by taking advantage of some language features to make the loops a little bit shorter. Again, you have to understand how strings work, but it's a more idiomatic way of writing C functions that work with strings or with arrays, and taking advantage of the fact that we can do pointer arithmetic and taking advantage of that null character sitting at the end. So we'll do that probably on Monday. But in the meantime, let's take a little break, go and get something to drink, go use the restroom. We'll come back in about 10 minutes and we'll go over the assignment.
Recording stopped.
That's what I was waiting for. I press a button and then there's a little pause as Zoom actually stops the recording.
So I'm having trouble getting the debugger to work. When I try, I get a message that I think it's, I need to try it again. Arg is not iterable. Does that ring a bell?
Is that coming like a little pop-up at the bottom of the screen?
Yes.
Oh, man, I've seen that before. And I don't remember what causes that. It's actually, it's an error coming from the IDE itself, not from the debugger.
Okay, right.
So it's actually a JavaScript error. The whole IDE is written in JavaScript. And so that's actually a JavaScript error that's popping up.
Okay.
So internally, what it means is that there's a bit of JavaScript code that expects to be handed like a string or an array of something, and it's not getting handed that. It's getting handed probably like a null or something that's not an array. And so JavaScript pops up this little error that says that thing is not an array. And so it's really actually a very general error that could happen almost anywhere in the code.
Okay.
So what happens, like what do you click on the moment that thing appears?
I created my launch.json.
Mm-hmm.
Target is ./a.out.
Mm-hmm.
CWD is workspace root. I'm in the root folder of my account. I've got a program there that I just called test, And all it does is create an array and modify values in the array. So I do clang -g test.c, and then I click on the debugger, or yeah, click on the debugger icon, and then it says debug a.out.
Mm-hmm.
I click on the little start debugging button, and I get that arg is not iterable.
Have you installed the native debug?
Yes. Native debug 0.25.1. Yeah.
Well, so you were successful in installing it, right? That went
Right.
Totally
It shows
smooth.
that it's installed. I can try uninstalling and reinstalling.
Did that change anything?
All right. All right, now it's not. I tried uninstalling the extension,
Mm-hmm.
and I'm trying to reinstall it, and it's not showing me anything.
Is it doing like what I've got here, which is
Yeah.
So I remember that was a problem last year, or maybe 2 years ago, where, see, this extension comes from the Open VSX registry, which is like a registry of extensions for Visual Studio Code. And there was some problem with the JavaScript running Thea wasn't able to talk in some instances with the VSX registry. And it was not a problem just with Thea. It was actually a problem with like every third-party project that was using the VSX registry, including Eclipse and some other ones. And so I guess what they said was like, it's not a problem with the Thea code, it's a problem with the VSX registry. They need to go change something on their end, and that was harder to do because they were a third party. But I guess they finally did fix that, but we're still seeing this issue here, and that might be what's causing this arg is not iterable, like the extension's not getting loaded correctly.
Okay.
I'm going to refresh the whole screen here. Actually, that's something that you might want to do is close your tab, go back to the launch window, and relaunch. Now nothing's coming up at all with the VSX registry. Almost like
Okay, well, at least we're having
they're
the same
down
problem.
or something.
Okay.
I'm going to have to play around with that a little bit.
Okay. So I looked up. Oh,
go ahead.
I looked up shadowing in C#,
Mhm.
and it's actually illegal in the language specification.
They don't allow it at all?
No.
Ah. So it's part of the language specification not to allow that.
Right. Yeah. So it's not a compiler setting in C#.
Interesting.
Yeah.
And you said it's an error, not even just a warning, right?
Right. Yeah. It won't compile.
I wonder why they elected to do that.
Well, I guess it eliminates, a possibility of errors.
That's true. But that could be something that could just be flagged as a warning. Like just let you know, hey,
Yeah.
you're doing this. Is that what you intended to do? In some of the languages I've worked with, like C and I used to be a big Perl programmer. That was one of my favorite ones. And both those languages allowed that shadowing. And there were times when I would, I think Java also allows the shadowing. There are times when I would take advantage of that.
Yeah.
Like I had a variable, and let's say that variable was counting, and then I temporarily wanted to change that value. Like let's say I'm scanning through an array, so I've got this I that's incrementing, but in one section of code I maybe want to jump ahead, like let's say by 5, and go look at something over there, and then return back to where I was. Okay. So rather than create a new variable that would keep track of what the original value of I was, I would just create a new scope.
Okay.
And then have that I jump forward, and then when it went out of scope, it would effectively jump back to where it was. So I could like temporarily move that value of the variable around and not affect the outer part of the program. In a language like Perl, which is used a lot for processing text files, I used that idea of shadowing a lot when I would maybe I'm going through a text file, and in one part of the text file, the delimiter between the fields was a comma. And that was the case for most of the text file. But there were sections of the text file where the delimiter switched to a colon, let's say, because it was generated by a different program that outputted to this file. So I would like set the field delimiter to be a comma at the beginning of the program, and then like halfway through I'd switch it to a colon, but then I wanted to switch back to what it was, and so I would just create a new scope. And that has a nice effect of making it switch back when I'm done. I don't have to then remember what that field delimiter was. I don't have to store it away in another variable. I just create a new scope.
Right. Well, not in C#.
Now I hate C#. I'll never use it because of that. I can see that this VSX thing is just hanging.
Yeah.
The other thing, what I was going to say earlier was, this version of Thea is actually an older version from a year ago, and there's a newer version out. It looks roughly the same. There are a few user interface tweaks here and there, but I compiled the new version for this class and then ran into some issues and decided that the issues weren't worth it, and I rolled back to the original version.
Okay.
And maybe this bug with the extensions has been fixed in the newer versions, and maybe I should explore that idea again of rolling forward. One of the other classes, the assembly language class, is using that new version, and they're not running into any issues, but they're not running into that issue because they're doing different stuff.
Right.
I think one of the issues, and this is really a minor issue, is in this older version, when you go File, New File, it asks you up front for the name of the file. And the advantage there is I can type in like hello.c or whatever.c, and then when it loads up the editor, it knows, oh, this is a C file. I need to turn on the syntax highlighting for C files. I need to do the indentation for C files. But in the newer version, when you go File, New File, it just opens up an untitled, and it starts out as a text file. And so you would have to then go and change what language this was.
Okay.
Or you would have to do in a very quick save, and save it as a
Right.
C file. But there was another way to create a file, and that was to right-click here, and then go New File, and then it will then ask you, what's the name of the
Okay.
file? That's in the new version. So if you did File, New File, it would give you an untitled, and if you did this ... New File, it would ask you. And so I told the other instructor, this is how you should have your students create a new file right here, so they can create files with the correct type right up front, rather than having to change it. And I thought, that's just like weird enough that I didn't want to change my videos.
Right.
I'll work on that later, because I already had instructions that say go File, New File, and then that would all break. So I decided to stay with the old version. So maybe I'll play around with the new version and see if some of those issues can be addressed easily. And maybe, hopefully, that'll fix the problem with the debugger. Question is, how would you use test-driven development in C? I've done that. There's a library called check that you can compile into your programs, and it gives you a whole bunch of functions for evaluating the return values from the functions that you write. So in test-driven development, you would write a bunch of tests before you wrote the code itself. So if we were writing a function called, let's say, string length up here, we would write some tests to make sure that string length was working, and then we would write the code for string length and make sure all the tests passed. And by having you write the test first, it helps you to kind of divorce yourself from looking at the code for the function and then modeling your tests after the code. It kind of forces you to think about how should this code behave before I write the code, and then make the code match that. So there's a library called check, and it's not as easy to use as the equivalent methods or classes in, like, let's say Java, because C doesn't have polymorphic functions. You can't write one function with different parameters like you can in Java. And so what that means is that you end up with, you can't just write one function called check and then a function call and its expected value, because that function might return an int, or it might return a double or a string. So you end up having to have a whole bunch of auxiliary functions called, like, you know, check string, check int, check float. But it works, and also the reports you get back from check are not that easy to understand. Like, it would come back and it would say, like, oh gosh, I don't remember. It would say, it would give you a number, which was like the number of tests passed or something like that, and that number would, like, sometimes not match up with the actual number of tests that were passed. And so you'd look at that and go, like, oh, it looks like all tests passed, but I'm getting an error. And so it was just weird. But nevertheless, that was how you did it. It was a library called check.
You've been using something similar in C++ called assert.
Yeah, same idea. That if your test passed, then it will
Output nothing.
nothing. If it failed, then you would get an error.
I was actually wondering, how do you go about, like, looking up the standard libraries for C or C++? Because I know, like, Java has the nice API, which is just nice to flip through.
I do a lot of Googling. Like, so if I want to look up string length, I go strlen, and then I usually put the word C on the end. And a good place to end up is, like, on this c++.com site.
Ah, okay. I keep ending up on that site. But there is no, like, standard, like, centralized place like Java has with the API.
No, I mean,
That's too
there's a command line, right? You can. This is the old way to do it.
But you can. Wait,
Man.
really?
Oh, we've removed these, but the old way was
that works.
yeah, if you have it installed.
Oh my! I did not realize man had a capabilities to that. Wow, that's really good to know. Thanks.
But most of the time, the stuff you find on the internet is basically
Same thing.
they took
copied,
this,
right?
yeah, copied and pasted it, and then just put it in here. So I used to show students the online manual, and then Google was just like easier, and everyone knew how to use it, and doing it from the command line just seemed esoteric and strange. But nevertheless, if you have those files installed, then it just works.
It's actually pretty useful for me because I do most of my programming like in Vim, so just quickly.
Now, the thing about the online manual here is I think there's 8 sections to the manual. Section 1, 2, 3, 4, 5, 6, 7, and 8.
Right.
Section 1 are like the user commands you would type on the command line, like ls. So it says, here's the ls manual out of section number 1. So when you say man printf, whoops, it tells you, here's the printf out of section number 1, which is the printf command that you type on the command line.
So you got to do the section number, which is...
Yeah, so you have to go like man, and now you have to
1.
know section 2 is for the really low level system library ones, like ones for like creating processes and memory management, and then manual section 3 is for the library functions. So if we wanted to find printf, we would search in manual section 3.
There we go.
If we search in manual section 2, I think it's going to say there isn't one, because that's not where you find those things. And then section 7 is for system administration commands. And I don't think like 4, 5, and 6 are used much anymore. So you'd find string length in section 3. But if you do man string length, there isn't string length in section 1 or section 2, so it'll just jump right to 3. So what I do is I go man the function I want, and then if I notice it brings it up in section 1, I go, oh, okay, I want it actually in section 3. Or I Google for it.
Oh, hey, section 6 is games and screensavers.
Ah,
It's kind of crazy they have just a special section for that.
That is funny.
how'd you find it? You Googled for that, didn't you, huh?
I did, what did I searched for man sections on DuckDuckGo, but there you go.
Oh yeah, section 5 I use quite a bit. That's where it tells you how the system files are formatted. Yeah, games, miscellaneous, system administration commands in section 8.
So there's a website I just found called commandlinux.com that has all the man pages.
Command what?
Commandlinux.com. Linux. No. There you go.
Let's see what's in section 6. Yeah, see, most of these are for graphical interfaces.
Right.
What I'm looking for is, what about the old text-based games?
Oh. Yeah, I don't think those are in here.
That's not there. Well, that's going. Oh, it's not there. No? Oh, a net hack. I got net hack on here. Net trick. That's what they call it, Star Voyager, to avoid any copyright issues. No? That's not going to work. What did it just install?
It's setting up star.
Is yours starting?
Well, no, I see it at the
Oh,
third
I mean,
to the
yeah.
last line that
Yeah,
it's
yeah,
setting
yeah.
up starboard there. But
Installed them to user games, of course.
okay, there it is.
Do I need a bigger screen to do this on?
Could be.
Don't know what I'm doing.
Looks like it's using N curses. I wonder if this terminal's not compatible.
It should be.
No. Oh, maybe it's not big enough.
Also a bunch of errors here. Cards. Sound cards. I don't have any sound. Oh, anyway, enough goofing around here.
Okay, yeah.
Recording in progress.
All right, this is the assignment for this week. This is called CSI, Computer Science Investigations. And the story goes that I was wandering around our campus the other day and I was taking pictures on a little digital camera. And when I got home and put the SD card into my computer to unload the images, it said that it didn't recognize the card. Now, as a computer programmer, I know that it's very unlikely that the SD card got completely erased. What probably happened was something just happened to the first few sectors or bytes on the SD card, and then the computer just can't recognize it. So what a forensic investigator would do if they, let's say, came to a crime scene and there was a computer there, is they would take the storage device, the SSD or the hard drive, out of that computer, and then they would make what's called an image of it. They would take a byte-by-byte copy of the entire contents of that storage device onto another storage device in order to preserve the evidence. And then they could, at their leisure, do some analysis on that device and find out what's in it. Even if the perpetrator deleted all their files or formatted the device, the files would still be there. Though the bytes would still be there, it would just be not viewable on your computer because the computer looks to see if there's a table of contents. And if it doesn't see that table of contents, or if it's empty, then it just won't show you the files that are there. But the files are still there. So that's what I did, is I took an image of that SD card. I copied all the bytes off of it and gave it to you. And your job is to go and find those JPEG images that are on that card image. Now, I didn't take very many pictures, so I know all the JPEG images are within the first 16 megabytes or so. So I actually truncated the image at that point. It was like a 8 gigabyte card, and I didn't need all of that, so I just truncated to the first 16 megabytes, and I know they're all in there. So to be able to find a JPEG image, you need to know a little bit about how files are structured on like an SD card and how JPEGs are structured as well. Just a moment. So the first thing you need to know is that a disk drive, whether it's an SSD or a regular standard hard drive, is basically just an array of bytes, starting at 0 and going on up. So when your computer needs to find a specific file on the disk drive, all it needs is basically what byte number on that device is that file stored at. And then it moves the read-write heads. If it's using a standard disk drive, it moves the read-write heads to that position on the platters and then starts streaming the bytes right off of the platters. Same sort of thing goes on with an SSD, although there's no moving parts. It just views it as just an array of bytes. But that array of bytes is broken up into smaller sections called blocks. And for historical reasons, each of those blocks is 512 bytes long, half a kilobyte. When you save a file on a disk drive or an SSD, that file will always start at one of those block intervals. So you'll never get a file that starts halfway through a block. It's always going to start at the beginning of a block and then grow outward from there. So if I store a file on here, and let's say it decides to put it in this third block, it might store the file like this. So it occupies the entire third block, the entire fourth block, and then part of the fifth block. This space to the right of the file, between the end of the file and the beginning of the next block, is called slack space. And that could be interesting to a forensic investigator if the the criminal had stored a file on their disk and then erased the file and then stored a new file there that was shorter than the original one. That slack space might contain some useful information, might contain some information left over from the file that was there before. So an investigator would want to look at not only the files on the disk and the files left over after formatting, but also what's going on over here. Is there anything interesting in there? Now, for me personally, I formatted the SD card before I put it in the camera, erased all the images, so the slack spaces on your card are going to be filled with zeros. So this space over here is just going to be all 0, 0, 0, 0. So there's going to be nothing interesting to look at there. Don't worry, if you look at the slack space, you won't find anything interesting at all in there. Okay, so files always start at the beginning of a block. As I said earlier, you'll never find a file that starts midway through a block. It always starts at the beginning of a block. Now, JPEG images themselves have what are called signatures, both at the beginning and at the end of the file, to indicate that it's a JPEG file. You can't rely on the file name extension because people can lie. You can actually have a JPEG image on your computer, but name it like .exe or .c. And then to a human, it looks like it's an executable or it's a C file, but actually it's a JPEG image. And most of the times your computer won't be fooled. If you have a JPEG image, but it ends in .c, if you double click on it, it'll bring it up in a JPEG viewer because it knows internally it's a JPEG because it looked at the first few bytes of the file and saw this signature. So the signature at the beginning of a JPEG file is 255, 216, 255, 224, or in hexadecimal, FF D8 FFE0. And there's another variant, depending upon what kind of camera took the picture, that fourth byte might be a 225 instead of 224. So JPEG images are always going to start with these 4 bytes, either this sequence or this sequence. And they're always going to end with these 2 bytes, 255, 217. So going back to our picture, it's going to start with like 255. Actually, I got a nice picture here, right on the screen. I'm drawing this picture. So the start of the file is going to have these 4 bytes, and then there's going to be a whole bunch of image data, and then these 2 bytes, and then the file will end. So what your program needs to do, is find this 4-byte sequence at the beginning of the file, scan forward until it finds this 2-byte sequence at the end of the file, and now you know where the beginning and ends of the files are. So that's generally the idea, to find these JPEG images, is to find this 4-byte sequence at the beginning of a block, and then scan forward until you find that 2-byte sequence at the end of the file, and now you know where the beginning and ends of the file are. We good so far?
Well, but then the next paragraph says that those could be inside a file. They
Correct,
don't necessarily
right.
at the end.
So these 4 bytes will always be at the beginning of the file, but they could conceivably be in the middle of the file as well, because this could just be pixel data, right? And these other 2 bytes over here, 255 and 217, that could be valid pixel data as well. They will definitely be at the end of the file, but they could also be in the middle of the file. So it's going to be up to you to figure out, how can I take 255, 217 in the middle of the file and the 255, 217 at the end of the file? You're going to have to figure that out yourself. And you might already have some ideas, and I would say save that until next week when we talk about this some more. So I've given you some starter code called recover.c. I'm providing for you a main. You don't have to touch this main at all. It calls read card, and then it calls recover. And recover is the function that you need to write. I've also given you a function called save JPEG. You pass it a pointer to where the JPEG image starts. the length of the image, how many bytes are in the image, and then what file name you want to use to save the file under. And then it will just simply copy the bytes that you tell it. So you tell it to start here, go for this many bytes, and what it will do is it'll create a file in your file system, write those bytes to the file, and then save it. So your job is to write the function called recover. And you can see that recover is given a pointer to the card data and its length. So you're going to have to write a function declaration that works with those parameters that are being passed to you. The C language provides a header file called unistandard and standardint.h, and those are used to define this type here called uint8_t. Basically, that's just an alias for character, but it's an unsigned 8-bit quantity. So this is kind of the standard way of specifying a byte. It's the equivalent to a byte in Java. So uint8_t gives you a type that is an unsigned 8-bit quantity. And that's what this array is, just an array of those things. All right, so you need to write recover. This is what the function declaration looks like. So you need to scan through the array of bytes looking for that 4-byte sequence. Then go and find that 2-byte sequence and make sure it's the one at the end of the file. And then from that you can compute the length of the file, and then you can call save JPEG. I've got a hint here. I don't know where to begin. I don't know how to tackle this. I'd say start with this. Try to determine how many images there are. Just look for those 4-byte sequences and count how many of them you find. Don't actually extract any data. Just count the images. That would give you a good place to start. As far as writing the names of the files, you might want to use a function called sprintf. Sprintf is just like printf, the one you've been using, except instead of printing something to the screen, it prints it into a string. So it's a way of formatting strings. If you want a string to have a specific format and you want to insert variables into that string, sprintf is a great way to do it. Let me show you an example. Let's say I want to have my computer just say hello followed by a number, and I want it to do that 10 times, like hello 1, hello 2, hello 3. So let's write a loop. Let's start the loop at 1 and go less than or equal to 10. And then I'm going to use, instead of using printf, I'm going to use sprintf just to get you the idea. So let's make a string. Let's call this out, and we'll make it 100 characters long. I'm not going to use all 100, but there they are. So normally I would go printf hello, comma, hello %d, and then my counter. But instead I'm going to use sprintf, and I'm going to print into this string called out. So you put the string first. So instead of displaying this on the screen, it's going to copy HELLO into this string, and then use the %d placeholder to put the value of this variable I into the string as well. And then I could just output that string to a file. I could use like putS to do that. Okay, hello 1 all the way up through hello 10. So I can use sprintf to format a string the way I want it. Now you might be asking, why didn't I just use printf here? Well, now we can use a string for other things. And the way we use it in the recover program is as a file name. So we want a file name that increments every time we save the file. So I want the first one called image1, and then image2, and then image3. So you're going to pass into save JPEG, the function save JPEG, the file name that you want to use. And it will use that file name to save the image as. So here's what's going to happen when you write this program. I can guarantee you it's not going to work the first time. I would start by just printing out the number of files, number of images you find there. And you might be pretty successful at that, but then when you go and actually try to recover the images, what's probably going to happen is you're going to recover some of the images, but not all of them. Maybe about half of them will work. So you click on them in your file browser over here, and the image will appear, within the editor section. But you'll find that some of them maybe only contain the top half of the image, and the bottom half is just blank. And that would happen if you have found that 2-byte marker in the middle of the image rather than the one at the end. So at the very beginning of a JPEG is information about how big the JPEG is, how many pixels wide, how many pixels tall. So the JPEG viewer knows to reserve space on the screen for an image that's that big, but your data stops halfway through. So you get image data for the top half and then blank for the bottom half. So that's going to happen if you found the marker, but it was midway through the image, not all the way at the end. The other thing that might happen is you might recover all of the images, but none of them are viewable. And that might happen if you're just missing a few bytes out of the image. Like maybe information at the beginning of the image about how big it is might be missing. So I'll show you next time something you can do, but I'll give you a hint right now. Actually, no, I'll show you right now. Let's use a website called, what was it called? Here it is. It's called HexEdit, but it's spelled HEXED.IT. And this is a nice website that allows you to view the contents of a file. All you have to do is drag and drop a file into this website, and you can view the contents of it. So what you're going to have to do is go to your IDE over here, download the file. Let's take this one here. So I'm going to highlight the file and then select download. Oh, I don't know why that says preparing. Let's do this again. That can sometimes happen if your session is timed out. Here we go. I guess we'll do it down here. File, there we go, download, there we go. So there's my file right there. And if I come over to the hex editor and drag that over into here, it shows you the contents of the file, character by character. So over here on the right-hand side, it shows you the characters in the file, and on the left-hand side, it shows you the actual bytes themselves. So if this was a JPEG image, we would be looking for that 4-byte sequence at the front and that 2-byte sequence at the end. Actually, let me go find a real JPEG image. Here's one. I'm going to bring it in. Okay, so here's FFD8, FFE0. There's that 4-byte sequence at the beginning. And then if we scroll all the way to the end, we can see it ends with FFD9. And that's that ending sequence. So the first 4 bytes needs to be that 4-byte sequence, and the last 2 bytes needs to be that ending sequence. Now you could drag that 16 megabyte image onto the card image onto this here, but it's huge, right? Scrolling will be really problematic because it's just a huge file. Nevertheless, you could drag one of your extracted JPEGs in here and just check. Just take a look. Is FFD8, FFE0, or E1 at the beginning? And does it contain that 2-byte sequence at the end? And if it's not at the end, you could search for it. Let's see, there's a way to do a search here. Oh, here, you can do like FFD9. Oh, let's see, we want to search for not integers. Not integers, not integers. Not integers. Let's try that again. There we go. So uncheck all these integer ones. We're not searching for integers. We're searching for the sequence FF and D9. And then it found it at the end here. So you could use this website to hunt through your extracted JPEGs and see if they're the correct format. Okay, I think I'm going to leave it at that for now and let you kind of play around with this over the weekend. And then we can come back on Monday and Wednesday and find out how you did and if you have any questions about this. I guess what I'll leave you with right now is, do you have any questions just right off the top of your head? Like you're looking at this going, I've already got some questions, and maybe I can answer them.
Well, the thing I'm trying to figure out is how to figure out if those 2 bytes are actually the end of the file or not. But I think that's part of what we're supposed to figure out. So
right, and there are some hints in this description.
Right.
But not too many hints. So maybe one thing to do is just try it by scanning forward and just see if you can extract some of the images. Because you do get kind of like a little kick when some of the images start appearing. Like, wow, I got some of them, right? And if you've been around our campus, you'll recognize some of the places that have been photographed. What I used to do back when we were actually in the classroom is I would have the students then go on a scavenger hunt. They would recover the images, and then I would say, go find those places on campus and take selfies there. And then come back, and the person with the most correct selfies, got like an extra point or two. And then some of the images were really obscure. Like they're all around campus, but some of them are like the corner of a building. Or a couple of them are like taken at really weird angles. So you might not recognize what it is until you turn the image sideways and go, oh, that's what that is. And then I would say I'm just not a very good photographer. I think what we might do next week, and this really doesn't have anything to do, I mean, it does have to do with the assignment, but if we have some extra time next week, is I could show you how a JPEG image is actually structured internally. So the easy way to do this assignment is to just find the end marker and then save the image, find the correct end marker. But if you're really feeling adventurous, could you actually decode the internal structure of a JPEG image and find the end that way? I'll leave you with one extra hint that's not written down there, and that is none of the images are larger than about 2 megabytes. They're all fairly small. So you could potentially take advantage of that little tidbit that I just gave you to help you. So when a JPEG viewer puts the JPEG up on the screen, it decodes the internal contents of the JPEG. And the JPEG is broken up into several different chunks. There's the header chunk that tells it information about how big the image is, and the bit depth of each of the pixels. This is an 8-bit JPEG or a 24-bit JPEG or a 32-bit JPEG. So there's that basic information up front. And then behind that is information about when the picture was taken, what kind of camera was used, GPS coordinates if you have them, exposure information, so meta information about the photograph. And then behind that is, I think it's color information. So basically information about what kinds of colors were used in this and what's standard of colors, like are you using sRGB or ARGB or NTSC. And then behind that is the actual pixel data. And then finally, so each one of those chunks has its own little 2-byte sequence that indicates the beginning of the chunk. And so a JPEG viewer is going to look for those JPEG sequences and basically leapfrog its way through the file in order to find the end. That's not what we're doing at all. We're just starting the beginning and then finding the end. But I might, if there's time, I might show you how to decode the actual internal structure of a JPEG. And then you can find the end that way by leapfrogging your way through the different sections of a JPEG and then find the end. And that's what your JPEG viewer is actually doing. See, if you give it a file that contains junk after the last 2 bytes, it'll pretty much just ignore that. Once it finds that 2-byte sequence at the end, everything beyond that is just not shown to you. And there have been people that use that little bit of trivia. Like, if you wanted to hide a secret message in a JPEG file, what you could do is just get an ordinary JPEG, one of a cat or something like that, and then using something like this hex editor, add some additional bytes to the end with your secret message in it. So when somebody views the JPEG, they just see a picture of a cat. But if you bring it up into this editor, you could find those extra bytes at the end and get your secret message. The viewer will ignore them, but you can see them with this editor that allows you to view the individual bytes. What that means is that you could actually put 2 JPEG images in a JPEG file. You could put an innocent one up at the front, and then a real one that contains a secret message, or one that contains like a map of where someone should go, back behind the first one. If you view the file in a viewer, you'll just see the first one. But if you can tell that viewer, start midway through the file, and then display the image from there, then you can display the second one. So that technique has been used as well to hide information. So there's all sorts of really cool stuff you could do. Now this image SD card that I've given you doesn't have anything like that in there, but there's no special images to look for. But nevertheless, it is something that a forensic investigator might look at are secret messages being hidden inside of these files that look just like JPEGs or PNGs or music files. Okay, so I think I'll leave you with that for now, and I'll let you play with it over the weekend, and let me know how you did when we come back on Monday.
Oh, hey, I remembered, or I think I remembered, did you say you set up student hours besides the one on Monday after class?
No.
Maybe I imagined that. Okay.
No. I mean, I have some on Tuesdays as well, but I'm actually in my office during that time.
Okay.
So the thing to do is, if you wanted to meet with me, is just make an appointment.
Okay. Is email the best way to do that?
Or a Canvas inbox probably work.
Or the Canvas inbox. Okay, great, thanks.
Yeah. Did you need to speak to me today?
I could if you have time.
Yeah, we can end the session and then go right into that.
Okay.
All right. So not right now. Give me a moment. So are there any other questions? All right. Well, I will see you all next week. And then if you want to switch over to the other one, I believe there's a link on Canvas with the Zoom ID for the other session.
Okay. For the
Student hours.
for the student hours.
Yeah.
Okay.
Yeah.
I'll find that.
Okay.
All right. Thanks.
Take care, everyone.
This weekend.
All right. Bye-bye.
Record.
And YouTube people, I will say goodbye at all because at this time as well, because I've got someone who wants to talk to me. So have a great weekend, everybody, and I will see you next week. Take care. Bye-bye.